In the ancient depths of time, before the first words were written or the first fires tamed, humanity's earliest ancestors would have raised their gaze to the night sky and found a vast, unyielding mystery. Imagine for a moment the world before knowledge, the world where the heavens themselves were a living tapestry, alive with shifting lights and moving patterns. The darkness was not empty. It was filled with stories, with omens, with gods and monsters drawn in points of light. It was a world where the boundary between myth and observation was blurred, and every star was a possible sign, every planet a wandering divinity. Night after night, year after year, the earliest skywatchers would have noticed that most stars adhered to an orderly rhythm, rising and setting, turning through the seasons like the gears of a celestial machine. But among these fixed stars, a handful broke the pattern. They wandered, drifting slowly across the sky, sometimes moving forward, sometimes appearing to pause or even move backward in a strange dance called retrograde motion. These wanderers, 5 in all, were Mercury, Venus, Mars, Jupiter, and Saturn, the only planets visible to the naked eye, and their unpredictable paths set them apart from the eternal constellations. In every culture, these 5 wandering lights were given special significance. To the Sumerians, Babylonians, Egyptians, Greeks, and Romans, they were not merely points of light but powerful deities, each with their own stories and domains. Mercury, so swift and elusive, became the messenger god, darting close to the sun's glare. Venus, the brightest of all, was the goddess of love and beauty, heralding dawn and dusk in a blaze of brilliance. Mars, burning red, was the god of war, his hue recalling the blood of battle. Jupiter, the king of planets, shone as a beacon of power and authority, while Saturn, slow and distant, was the ancient god of time and harvest, its pale light a symbol of endurance and patience. For millennia, the planets shaped the calendars and rituals of civilizations. They marked the seasons of planting and harvest, the timing of festivals, the fates of kings and empires. Astronomers in Babylon in the 2nd millennium BCE kept detailed records of the planets' positions, creating the earliest known astronomical tables. The Egyptians aligned temples with the rising of Venus, and the Mayans built complex calendars tracking the movements of Venus and Mars. The Greeks, inheriting Babylonian wisdom, named the planets after their gods, and the Romans later adopted and adapted these names. Yet for all their knowledge, the ancients were trapped by a geocentric vision, the belief that Earth stood at the center of all things. The stars, planets, and sun revolved around us in perfect crystalline spheres, an idea formalized by Aristotle and crystallized by Claudius Ptolemy in his 2nd century CE Almagest. This model, elegant and enduring, held sway for nearly 1,500 years, its circles and epicycles accepted as cosmic truth. But the planets, with their strange wanderings and retrograde loops, posed a persistent challenge to this order. Why did Mars sometimes appear to move backward against the stars? Why did Venus never stray far from the sun? And why did Mercury skim so close to the horizon? The geocentric model offered explanations, but they grew ever more convoluted as observations improved. Centuries passed, and the slow accumulation of knowledge began to tip the scales. In the 16th century, a Polish cleric named Nicholas Copernicus dared to look at the sky with new eyes. Drawing on ancient Greek ideas, Copernicus proposed a heliocentric cosmos, one in which the sun, not Earth, was at the center, and the planets, including Earth, moved in ordered paths around it. Published in 1543, his De Revolutionibus Orbium Coelestium was a quiet revolution, a turning point that would eventually sweep away the old certainties. Yet even Copernicus's model was not enough to reveal the hidden planets. For that, humanity needed a new tool, a way to see further and sharper than ever before. In the early 17th century, the telescope emerged in the workshops of Dutch lensmakers and quickly found its way to the hands of Galileo Galilei in Italy. Galileo's telescopic discoveries, mountains on the moon, the phases of Venus, Jupiter's 4 largest moons, offered irrefutable evidence that the heavens were not perfect and unchanging. Saturn, seen through Galileo's primitive scope, appeared to have strange ears, a hint of its rings, though their true nature would remain hidden for decades. Still, the known planets remained those visible to the naked eye, and for the next 2 centuries, the solar system seemed a closed family, bounded by Saturn's slow circuit. Yet the age of discovery was dawning, and with it came the expansion of human vision. The story of the next planet's discovery begins not with a professional astronomer, but with a man of music and self-taught science. William Herschel, born in Hanover in 1738, came to England as a composer and musician, but his passion for the stars led him to grind his own mirrors, building telescopes of unprecedented power. On the night of March 13, 1781, while surveying the constellation Gemini, Herschel noticed an object that did not appear as a point, but as a tiny pale disk. At first, he suspected a comet, but its motion was too slow and regular. Over weeks of observation, it became clear. Herschel had found a new planet, the first since Antiquity. The discovery of Uranus was nothing short of a sensation. Overnight, the known size of the solar system more than doubled. Herschel, ever loyal to his adopted homeland, proposed naming the planet Georgium Sidus in honor of King George III, but the astronomical community preferred the mythological Uranus, father of Saturn. The planet's pale blue-green color, visible only through a telescope, and its slow, stately motion made it an object of endless fascination. The tale of Uranus did not end there. As astronomers charted its orbit over the ensuing decades, they noticed slight deviations, as if the planet were being tugged by some unseen force. This mystery became one of the great scientific detective stories of the 19th century. 2 mathematicians, John Couch Adams in England and Urbain Le Verrier in France, independently calculated where an unknown planet must lie to cause the observed perturbations in Uranus's path. Le Verrier's calculations reached Johann Gottfried Galle at the Berlin Observatory. On the night of September 23, 1846, Galle and his student Heinrich d'Arrest turned their telescope to the predicted spot and, within an hour, discovered Neptune, a faint blue world lurking at the edge of visibility. Neptune was the first planet discovered by mathematics rather than by chance, a triumph of human intellect and collaboration. Its discovery confirmed the predictive power of Newton's laws and cemented the reputation of astronomy as a science grounded in reason as well as observation. Neptune's own story is rich with intrigue. Its largest moon, Triton, was discovered just weeks later by British astronomer William Lassell. Triton's retrograde orbit suggests it was once a wandering object, captured by Neptune's gravity. Neptune's atmosphere, studied by Voyager 2 in 1989, revealed winds faster than any in the solar system, over 2,000 kilometers per hour, along with storms the size of Earth itself. Yet even as Neptune's orbit was being mapped, questions remained. Subtle anomalies in Uranus's and Neptune's orbits led astronomers to hypothesize yet another planet, Planet X, lurking beyond Neptune. The search for Planet X was fueled by both calculation and hope, and it led to the most famous false positive in planetary history. In 1930, a young American astronomer, Clyde Tombaugh, was tasked with searching for this elusive world at Lowell Observatory in Arizona. Night after night, Tombaugh compared photographic plates, looking for a moving pinprick among millions of stars. On February 18, 1930, he found it, Pluto, a tiny world far beyond Neptune. Pluto was hailed as the 9th planet, its discovery celebrated as the fulfillment of Percival Lowell's prophecy. But Pluto, unlike Uranus and Neptune, was a different kind of world. Over time, astronomers realized it was much smaller than first believed, smaller even than Earth's moon, and its orbit was highly eccentric and tilted, crossing inside Neptune's path for part of its journey around the Sun. For decades, Pluto reigned as the 9th planet, a distant, icy enigma. Technology, as always, changed the story. The late 20th and early 21st centuries saw the rise of powerful digital detectors and surveys that scanned the skies for faint, slow-moving objects. In 2005, astronomers led by Mike Brown at Caltech discovered Eris, an icy world in the distant Kuiper Belt, slightly larger than Pluto. The discovery of Eris and other trans-Neptunian objects forced a rethinking of what it means to be a planet. In 2006, after intense debate, the International Astronomical Union redefined the term planet, relegating Pluto, Eris, Haumea, Makemake, and others to the category of dwarf planets. This decision sparked controversy and nostalgia, as generations who had grown up learning about 9 planets mourned the loss of Pluto's planetary status. But the solar system's story did not end there. The discovery of the Kuiper Belt, a vast ring of icy bodies beyond Neptune, transformed our view of the solar system from a neat family of 9 to a sprawling, dynamic population of worlds large and small. The Kuiper Belt, theorized by Gerard Kuiper in 1951 and confirmed with the discovery of objects like Quaoar and Sedna in the 2000s, is a relic of the solar system's formation, a frozen graveyard of planetesimals that never coalesced into a single world. Even further out, the hypothetical Oort cloud, a distant spherical shell of icy bodies more than a light year from the Sun, may be the source of long-period comets, cosmic visitors that plunge into the inner solar system before disappearing for millennia. The Oort cloud remains unobserved directly, but its existence is supported by the strange orbits of comets like Halley and Hale-Bopp. The modern quest for planets has expanded beyond the boundaries of our solar system. In 1992, astronomers Alexander Volscian and Dale Frail discovered the first exoplanets, planets orbiting a pulsar, a rapidly spinning neutron star. In 1995, Michel Mayor and Didier Queloz announced the discovery of 51 Pegasi b, the first planet found orbiting a sun-like star. This hot Jupiter, circling its star in just 4 days, shattered assumptions and opened the floodgates. Since then, missions like NASA's Kepler and TESS have revealed thousands of exoplanets, gas giants, rocky super-Earths, ice worlds, and planets orbiting in their stars' habitable zones. Some orbit binary stars, some are scorched by close orbits, some are so far from their suns that their years last centuries. Planets with 2 suns, like Tatooine from Star Wars, are real. Some worlds are so close to their stars that their surfaces are oceans of lava. Others are shrouded in clouds of glass or diamond rain. The diversity is staggering, and the lesson is clear. Planets are not rare jewels, but common threads in the fabric of the cosmos. Back within our own system, each planet tells its own story, each a world of wonders. Mercury, the innermost, is a place of extremes, where daytime temperatures soar to 430 degrees Celsius and nighttime plunges below on 180. Its day is longer than its year, and its surface is battered by impacts, a testament to the solar system's violent youth. Venus, wrapped in thick clouds of sulfuric acid, is a hellish world where surface temperatures can melt lead and atmospheric pressure crushes spacecraft in hours. Yet radar mapping has revealed mountains, volcanoes, and highland plateaus, evidence of a geologically active planet. Earth, the blue jewel, harbors life, oceans, and continents shaped by plate tectonics. Our moon, once believed to be unique, is now known to be just one of hundreds of moons that orbit planets in our solar system. Mars, the red planet, is a world of ancient riverbeds, dust storms, and the largest volcano and canyon in the solar system, Olympus Mons and Valles Marineris. Robotic explorers have found evidence of water ice, salty brines, and perhaps the lingering possibility of life. Jupiter, the gas giant, is a planet of storms and stripes. Its great red spot a hurricane larger than Earth that has raged for centuries. Its family of moons includes volcanic Io, icy Europa with its subsurface ocean, massive Ganymede, and cratered Callisto. Jupiter's magnetic field is the strongest of any planet, and its radiation belts are deadly to unprotected spacecraft. Saturn, with its magnificent rings composed of billions of icy fragments, is orbited by Titan, a moon with lakes and rivers of methane and ethane, a thick atmosphere, and organic chemistry that may resemble the conditions of early Earth. Enceladus, another Saturnian moon, spews geysers of water ice and organic molecules from a hidden ocean, raising hopes for life. Uranus, pale blue and tipped on its side, rotates almost perpendicular to its orbital plane, giving it extreme seasons that last decades. Its moons and faint rings are the legacy of a cosmic collision, and its atmosphere contains mysterious dark spots and storms. Neptune, deep blue and windswept, is home to the fastest winds in the solar system, and a dark storm called the Great Dark Spot. Its moon Triton orbits backward, and is believed to be a captured Kuiper Belt object, its surface marked by nitrogen geysers. Pluto, once ninth, now a dwarf among dwarfs, surprised the world when NASA's New Horizons spacecraft flew by in 2015, revealing a landscape of mountains made of water ice, smooth nitrogen plains, and a thin blue atmosphere. Pluto's heart-shaped region, Tombaugh Regio, became a symbol of the planet's enduring place in human imagination. Beyond Pluto, the Kuiper Belt teems with worlds of ice and rock. Eris, Haumea, Makemake, Sedna, and others each possess unique traits. Haumea's rapid rotation distorts its shape into an ellipsoid. Makemake is bright and distant. Sedna follows a wildly elliptical orbit that takes it far beyond the known planets. Meanwhile, astronomers continue to search for a possible Planet 9, a massive world hypothesized to explain the peculiar orbits of distant Kuiper Belt objects. If it exists, it may be 10 times the mass of Earth, orbiting the Sun at a distance of hundreds of astronomical units, taking tens of thousands of years to complete a circuit. The march of planetary discovery has been driven by curiosity and by the relentless improvement of our technology. The earliest telescopes were poor by modern standards, but they shattered the old worldviews. Today, observatories on mountaintops and satellites in space peer deeper and sharper than ever. Keck, VLT, Hubble, and the new James Webb Space Telescope, each a tool for unveiling the unknown. Spacecraft have transformed the planets from distant lights to living worlds. Pioneer 10 and 11, Voyager 1 and 2, Galileo, Cassini, Juno, New Horizons, each mission has revealed new wonders. Voyager 2 remains the only spacecraft to visit Uranus and Neptune, its images of their moons and atmospheres still the best we have. Cassini orbited Saturn for more than a decade, discovering new moons, probing Titan's haze, and diving through the rings before its fiery end. New Horizons dashed past Pluto, sending home the first close-up images of a world once no more than a faint point of light. Every discovery brings new questions. Why is Uranus tipped on its side? What powers Neptune's fierce winds? Could life exist in the subsurface oceans of Europa or Enceladus? Does methane on Mars hint at microbial activity, or is it a geological ghost? How many worlds orbit other stars, and how many are habitable? Are we alone, or is life a common thread in the tapestry of creation? The story of the planets is also a story of people, of astronomers who gave up sleep to scan the skies, mathematicians whose calculations turned invisible worlds into reality, engineers who built machines to cross the void, and dreamers who imagined other worlds long before they could be seen. It is a tapestry woven from patience, brilliance, and a hunger for knowledge. The planets themselves are like characters in a cosmic drama, each with its own personality, history, and secrets. Mercury, battered and seared, Venus, shrouded and infernal, Earth, vital and teeming, Mars, dry and wistful, Jupiter, vast and stormy, Saturn, adorned and enigmatic, Uranus, tilted and pale, Neptune, storm-swept and blue, Pluto, lonely and surprising. Each has moons, each has rings, each is a world unto itself. And beyond, the search continues. The Vera Rubin Observatory, set to scan the sky every few nights, may reveal thousands of new minor planets. The James Webb Space Telescope will probe the atmospheres of exoplanets, searching for the signatures of life. Robotic explorers will journey to Europa, Titan, and beyond, perhaps one day to the icy reaches where the sun is just another star. Curiosities abound. Mercury's core is enormous, suggesting a violent past. Venus rotates backward, a day longer than its year. Mars has dust devils taller than skyscrapers and ancient river valleys frozen in time. Jupiter's great red spot shrinks and grows, its cause still a mystery. Saturn's rings may be young, perhaps only a few 100 million years old, or the remnants of a destroyed moon. Uranus and Neptune, almost twins in size, could not be more different in their internal heat and magnetic fields. Pluto's surface is renewed by the slow flow of nitrogen glaciers, its thin atmosphere freezing and sublimating with the seasons. The more we know, the more wondrous the story becomes. Each world is a laboratory, a chapter in the history of the solar system, a clue to our own origins. The common elements, hydrogen, helium, carbon, oxygen, are stirred and shaped in myriad ways, giving rise to landscapes and climates as diverse as the imagination can conceive. So how and when were the other planets discovered? The answer is a journey through time and space, from ancient skywatchers who mapped the wanderers by eye, to Renaissance astronomers who challenged old dogmas, to Victorian mathematicians who summoned Neptune with pencil and paper, to modern scientists who find new worlds in streams of digital data. It is a story of expanding horizons, of boundaries pushed ever outward, of curiosity rewarded and expectations overturned. As you look up at the night sky, know that every wandering light, every faint dot, every point of brilliance is a world with its own story. Some were known to the ancients, some revealed by telescopes, some predicted by mathematics, some glimpsed by robotic eyes a billion kilometers from Earth. Yet all are part of the same solar family, bound by gravity and time, each a step on the path of discovery. The journey is far from over. With every new instrument, every new mission, every new insight, we come closer to understanding not just the planets, but our own place among them. The story of planetary discovery is the story of ourselves, a story of wonder, ambition, and the unending desire to know what lies beyond the horizon. And as long as there are eyes to look up, minds to ponder, and hearts to dream, the adventure will continue, across the darkness, across the ages, across the endless, star-strewn sky.